Good evening, millennials. Today we'll be looking at an easy LeetCode problem often asked in the starting rounds of FAANG interview companies. This is the 53rd problem in the LeetCode website called Maximum Subarray. So let's read the problem and understand the approach and try to code the shortest solution possible. So let's read the problem statement. Given an array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. Okay, seems pretty straightforward. A subarray is a contiguous part of the array. Nums is given as this and the output is given as 6 because the maximum contiguous part of the array or the subarray is 4, 1, 2 and 4 minus 1, 2 and 1, which has the sum 6. And there is no larger sum than this, as you can see. When nums is 1, you get only 1. And when it's this whole array, you get the sum of all the elements, which is 5 plus 4 plus 7 plus 8 minus 1, which is 23. And you know the nums.length is 10 power 5, and each of the numbers is between minus 10 power 4 and 10 power 4. Since the nums length is 10 power 5, you need an order of n solution. So there is a follow-up. If you want, you can do, because if you have figured out the order of n solution, try using the solution using the divide and conquer approach, which is more subtle, but it will take order of n log n. So I'll be discussing that in another video, but for here we'll look at the order of n solution. What we can basically do is, from the starting, we can keep on adding the elements and have it in a variable called current sum. And for each position, we can update the maximum sum up till that point. And once we reach the last, we would get the maximum sum possible, because at each position we always calculated the maximum. One thing we might need to notice is that the current sum at a point can become negative, say minus 2, minus 3 and so on. At that time, we need to make the current sum as 0 to make sure that we process it correctly from the next element. Otherwise, the maximum sum will become wrong, because only when there is a 4, say assume here minus 2, 1, minus 3 and 4, the maximum sum here is 4 and not minus 2 plus 1 minus 3 and plus 4. It's just 4. So you just need to replace this by 0 while calculating the maximum sum. Okay, let's try to write the shortest code possible. So I have two variables as already discussed, current sum, which will be 0, and another sum, max sum, which I'll replace it with the nums of 0. So this is because I can put it as 0, but what if all the numbers are negative? So in that case, I need to replace it by the numbers of 0, because 0 will be greater than the maximum sum, and in the constraints we have minus 10 power 4. Even though we will update max sum at every point, 0 will still be greater than this. So we need to put max sum as either int min or nums of 0. So now I'll just iterate through the numbers vector. So for auto num colon nums, what do I do is, so the current sum will be maximum of 0 comma current sum. This maximum of 0 is just to indicate that it's not become negative till that point, and to that I need to add the current number, which is num, since I'm iterating the numbers. And max sum would be maximum of max sum comma current sum up till that point. So when we do this for all the numbers, at the end in the max sum variable we'll have our maximum subarray sum. So we just return the max sum. Let me just run this code. Yeah, it passes. So let's just go through this example. So initially current sum is 0 and max sum is minus 2, and during the first iteration current sum becomes minus 2 and max sum still becomes minus 2, it still remains as minus 2 because it's nums of 0. And when I go to 1, the max sum, the current sum will become 1, and max sum will also become 1 because we are taking max of 0 and minus 2. And when we go to minus 3, the max sum will still remain 1, but the current sum will be 1 minus 3, which is minus 2. And when we go to 4, the max sum will be 4 and the current sum will also be 4. And from here till minus 1, 2 and 1, we would get the maximum sum as 6, which is our required output. After that, the max sum won't change because of this minus 5. So let me just submit this solution. I've just submitted a few times to find the shortest code, and as you can see, this is a 2-liner code which is the shortest and beats most of the solution. If you have a better approach or better order of n approach, please leave it down in the comments below. We are always welcoming positive feedback. Thank you.